Joe's spoken here many times, some of our very coolest talks. One of our favorite speakers, Joe's an independent security researcher and just has a lot of great knowledge to share. So looking forward to this talk. So I will hand it over to you with that, Joe.
My name is Joe, and I do not have a time machine. I am not going to tell you how to travel through time, but I am going to tell you about a real problem that I actually ran into. I swear this is a real problem. I need to call this function 12 milliseconds ago. So the first thing I tried, of course, is, can I call the delay function with a negative value? Unfortunately, no, delay takes an unsigned. So this method isn't going to work. I needed another solution because honestly, I do need to call this function 12 milliseconds ago. Here's the problem I have. An event occurs. I need to call a function 12 milliseconds before that event occurs, but it's difficult to do this, and it would be really easy if I could simply call the delay function with a negative value, but that's not going to work. So I needed to come up with another solution. And there is a way to do it, which is the way that dash cams work or flight data recorders in an airplane. You can maintain a sliding window into a circular buffer of events. And that gives you the ability to look backwards in time after an event has occurred. But the interesting thing about this is this only works for a function that watches the world but doesn't change it. I needed to call a function that has side effects. I'm calling a function that fires a laser. It changes the state of the world. I can't call that function early, hoping that maybe the event will occur sometime in the future. To do that, the best analogy I could think of for that would be the ballistic parachutes that some aircraft have. You can deploy the parachute after an emergency has occurred and it brings you safely to the ground, but you can't fly around with a parachute behind you all the time. You can't deploy the parachute ahead of the event occurring because obviously the airplane isn't going to work. So how do you solve this problem? The following solution only works for repeating predictable events, for events that occur at predictable regular intervals, but it wasn't enough to solve my problem. So here's the problem. The event occurs, and I want to call my function 12 milliseconds before that event. The interval between events is known. The way that I actually solved this problem was by waiting until the event after the event that I wanted occurs. I then call the delay function for an interval of the interval between events minus 12 milliseconds, which allows me to put the target exactly 12 milliseconds before the event after the event that I want. The solution does add automatic latency of 2 times the interval between events, but it solved my problem. This is how I call a function 12 milliseconds before the event occurs by cycle counting between events. And I wait for one event after that, then start counting cycles. I count cycles up until 12 milliseconds before I know the next event will occur and call the function then. This solved my problem. I swear this was a real problem that I ran into. The solution only works for repeatable, predictable events that occur at known intervals. I really want to call my function 12 milliseconds before this event in red, but I can't do that. So instead, I wait for the event in black to occur at a known predictable interval later. And at this point, I start counting cycles. And I count cycles for exactly the interval between events minus 12 milliseconds. And when my timer expires, now I know the exact time to call my function 12 milliseconds before the next event will occur. It solves my problem. If I had a time machine, it would have solved my problem a lot more straightforwardly, but I don't have a time machine, so I wasn't able to do that. I ended up doing a lot of reading in science fiction while searching for a solution to this problem. And I ran across a very interesting story. It's a one-page science fiction story. It was published in Nature a bunch of years ago, but it has in it the solution, exactly the solution I want. I brought copies. You can read this story if you want. It's a science fiction story about a negative time delay. What could you do if you had a negative time delay function? So read the story; it'll melt your brain. There's another science fiction story that I was reading about time travel, and it was about the Guardians of Time. The Guardians of Time are very serious about their training. Their training lasts for years and years and years, and the final exam in the Guardians of Time training is you have to go back in time and assassinate someone. What makes it interesting is the person you have to assassinate knows you're coming. They know what direction you're coming from, and they know exactly when you're coming. And they know exactly how you've been trained, because the person you have to assassinate is yourself 2 seconds ago. That's the final exam. That story melts my brain. Maybe if I read that story a few more times, I will eventually understand it. But at this point, I do not completely understand it. Anyway, this was my saga for how I managed to call a function 12 milliseconds ago. Real programming problem that actually did come up in the building of this device. That's it.